question number 6 is a continuation to question number 5 previously, but this time you need to make the diameter of the portion B to C smaller. Previously it was 46. This time you need to make it smaller with the condition that the maximum shear stress in the assembly would not increase. Okay, this is the solution of the previous question number 5, and we end up with the stress value 77.62 for the portion A to B, then 62.7 for the portion B to C, then 20 for the portion C to D. Obviously, for the portion B to C, it is not going. It's not the highest stress in the assembly, so the failure of the overall assembly is governed by the portion A and B because it is having the higher stress. We can change the diameter of the portion B to C so that it becomes smaller. By making the shaft smaller, we expect the stress to increase, but as long as it is not going to exceed the stress value of 77, that will be fine, because by doing so, by maintaining the stress value to be equal or less than 77, we are fulfilling this requirement. The maximum shear stress in the assembly would not increase. Okay, let's work on it. We are going to use the same equation, the shear stress equations, and also the polar moments of inertia equations. So if I substitute the inertia J into the torsional stress equation, and I'm going to get these equations: pi over 2 radius power 4. So it can be simplified because lowercase c is the same thing to lowercase r. So I end up with 2 pi 2t divided by pi radius power 3. Okay, what should I use for the tau? Obviously, this is the value. This is the value for the shear stress tau. It should be used over here. What should I use for the torque? Phi. We are referring to the portion B to C, so it is going to be 1.2 kilonewton meter, and the only unknown is the radius r. So if we solve for that radius r, it is going to give you 0.02143 meter, and the diameter is 42, is twice the radius, 42.86 millimeter. It is smaller than the previous diameter of 46, but that is what we want to achieve, and it is limited to this. This is the smallest you can apply, so that the stress for the whole assembly will not be exceeding this value. It will not increase. That's question number 6.